Hello everybody, this is Miss Bushra. Welcome to math class. Today we'll be talking about syntactic division. So dividing polynomials by a monomial using the syntactic division. So to do this, you have a few steps to follow. So the first thing to do is to identify the coefficient of your polynomial. So you have x cubed, coefficient that comes with is 1. Then you have your coefficient -2, so you need to identify them and write them back here. You have 1, so write them back here, -2, the -5, and 6. So what you have to do is to draw your division lines. Then you have to solve the monomial x minus 3 is equal to 0. So if you take the -3 to the other side, you get 3. So you'll be writing here 3. So let's start our division. How to do the division is you need to follow a few steps and repeat them all the time. This is how it's going to work. So you drop, first step to do is to drop the first coefficient, which is 1. Drop it down here, 1. Now, proceeding over the lines here in this area needs a multiplication, and proceeding inside the lines here before this line here needs addition. So if we are proceeding here, we need to add, and if we are proceeding here, we need to multiply. So the first, you need to multiply 1 by 3. The result is 3. You'll be writing it here inside 3. So 3 is the result of multiplying 3 by 1. So 3 is equal to 3. Write it back here. Then inside the lines, you need to add. So what are we are going to add? Actually, vertically, you need to add these coefficients to each other. So 3 plus minus 2 is equal to 1. Be writing the 1 here. Then again, I proceed outside the line. I need to multiply 1 by 3. So it's equal to 3. I write it here. Then again, I need to proceed vertically each time. So I need to add 3 to -5, which is equal to -2. Then again, if here I need to proceed outside the lines with multiplication. So I multiply -2 to 3, which is -6. So I write it right here. Then again, vertically, I need to add these numbers to each other. -6 plus 6 is equal to 0. I'll be writing here 0. The fact is, the syntactic division is much more easy comparing to a line division. So what are these? This is the divisor, and this is your polynomial function. These are the coefficient of your polynomial function px, and these are the coefficient of the quotient, the new polynomial function called qx, with these different coefficient here. Then if you have, for instance, let's erase this part here so it be clear. Now this one, if you proceed from the right to the left side, this one is called here a remainder, like in a log division, and this is the constant. This is degree 1, this is degree 2. So if you have a plenty of numbers, you will continue with just numbering. So how you write it back this way, -2, I'll be writing the -2. This is a constant. This is degree 1 that comes with x. Okay, this is the coefficient that comes with x, degree 1. 1 times x, degree 1. Here you have plus, and you have 1 times x, degree 2. So constant, degree 1, constant, degree 1, degree 2. So these coefficient here come in here next to their terms x squared. So if you simplify this, your qx is going to be 1 times x squared is qx. 1 times x squared is x squared. 1 times x is x. and you have -2. So this is your quotient here. Quotient is equal to x squared plus x minus 2. Now let's try to see another example. Now you have another polynomial function. So the first step to do is to identify the coefficient and write them back down. So I have x cubed, I have 1 coming with x cubed, so 1. With x squared you have 5. With the x you have 7. And the constant 2. Now divided by x plus 2. So you need to solve it for 0. So then the value that cancels out x plus 2 is equal to -2. If you take this plus to the other side, you get -2. So we'll be dividing for -2. -2. Then I proceed the same thing. So I need to bring down the 1. So outside of the lines, we are going to multiply. So I'm multiplying here the 1 by -2 is equal to -2. I'll be writing it here, -2. Then I add, vertically you need to add 5 added to -2 is equal to 3. 3 multiplied by -2 is equal to -6 comes here. Then proceeding vertically needs an addition. So adding 7 to -6 will give you 1. Then 1 times -2 is equal to -2. Then proceeding vertically with addition, adding 2 to -2 is equal to 0. And we stop here. 0 is your remainder. And you have, if you see your quotient here, is going to be written this way. 1 here, this one, constant, coefficient of degree 1, coefficient of degree 2. So I will 1 constant, 3 is coefficient of degree 1, and the 1 is coefficient of degree 2. Constant 1, 2. So you have qx is equal to x squared. 1 times x squared is equal to x squared plus 3x plus 1. So this is the result of dividing px by x plus 2. Now let's see another example. In this time, we have to divide a polynomial function px by x minus 2. So we need to write back the coefficient here. So 1, -2, 3, -4. So you need to identify the coefficients here, then write them back down. Then divided 2, we need to solve x minus 2 equal to 0 to find out that x is equal to 2. So we need to divide by 2. Then what you do is, again, you drop down the 1. Then outside of the lines, you need to multiply. So 2 multiplied by 1 is equal to 2 here. -2 plus 2 is equal to 0. 0 times 2 is equal to 0. Then 3 plus 0 is equal to 3. Then 3 times 2 is equal to 6. Then 6 -4 is equal to 2. And division is over. We stop here. Then you can see this time the remainder is not equal to 0. So how I'm going to write in this? Qx is equal to, as you see, a constant degree 1, degree 2. So constant 3 and something 0 times degree 1 plus 1 times degree 2. So constant degree 1, degree 2. Then this time we have a remainder. So the 4 is going to be written like this, plus the remainder comes here, 2 over the divisor, x minus 2. All the time it's written the same way. So let's try to simplify what we have. 1 times x squared is equal to x squared. 0 times x is equal to 0 plus 3, this 3 here, plus added to 2 over x minus 2. So this is qx. This is the quotient of dividing px by x minus 2. So this time we have a remainder. So each time you have a remainder, you write plus the remainder plus the remainder, which is 2, the remainder, divided by your divisor. In our case, my divisor is x minus 2. So you write it back here as a denominator, as a fraction, as a rational number here. Now, let's see the last example. The last example is to divide 6 minus 2x4 minus x squared plus 2 by x minus 1. So again, I need to identify the coefficient. But before doing this, I need to talk to you about something. You see, you have here we have x6. Then normally, in general form of polynomial function, you have if you have degrees, you need to order them from the largest to the least. So we have degree 6. We do not have degree 5. We have degree 4. We do not have degree 3. We do have degree 2. We do not have degree 1. And we have a constant. So before proceeding in synthetic division, please be aware of the next thing, that you need to take in consideration even the terms that are not in here. I mean, for instance, if you have here x6 and you have no x5 term, you need to write 0, because if you do not use the terms that are zeroed, the result will be different. So while writing the coefficient, I'll be writing 1 for x6, I'll be writing 0 for x5, I'll be writing -2 for x4, which is this. Then I'll be writing 0 again for x3, we don't have it. Then -1 for x2, then 0 for x, then +2 the constant, the last one. And there is no harm actually in using the zeros, because anyway 0 times x5 is equal to 0, and 0 times x3 is equal to 0, and 0x times x is equal to 0. That's the same thing as you're not writing them. Now divided by here, if you solve x -1 is equal to 0, if you take x to the -1 to the other side, you get 1. So we'll be solving them for 1. Then I drop down this one. Here, I might change the color. So I have 1. Now outside of the lines, we need to multiply, and vertically we need to add. So 1 times 1 is equal to 1. 1 added to 0 is equal to 1. Then 1 times 1 is equal to 1, and I'm writing it back here. Now -2 plus 1 is equal to -1. -1 times 1 is equal to -1. Now 0 plus -1 is equal to -1. -1 times 1 is equal to -1. -1 plus -1 is equal to -2. -2 times 1 is equal to -2. 0 plus -2 is equal to -2. -2 plus 1 is equal to -2, or -2 times 1 is equal to -2. Now vertically we need to add them, plus 2, -2 is equal to 0. Then the division is over. You can see that your remainder is equal to 0. So how do we write this? The quotient, your result, is going to be written this way. So if you need, you can start from the right to the left. This is the remainder, the leftover. Okay, so this is the constant, -2. This is the term of the coefficient that comes with the term degree 1. So if you do the math from right to left, if you count from right to left, you will have constant, degree 1, degree 2, degree 3, degree 4, degree 5. So what I'm going to do is I'm just writing them back down. So what do I have is I will write them directly. So take here -2, the constant. Degree 1 means x, so minus 2x. Degree 2 means x squared, so x squared with a negative here, the coefficient that comes with. Degree 3, x3 with a here -1. Degree 4 is 4 with a +1. Degree 5 with a +1 too. So actually this is the quotient. This is the quotient of dividing the polynomial function px, the polynomial function px on x minus 1. So the quotient of dividing px by x minus 1 is equal to qx, this all of this polynomial, new polynomial function. So I believe that synthetic division is solving a lot of problems, and is very easy and a kind of shortcut, comparing to long division. So yes, using synthetic division is very useful, and we gain a lot of time. Now, in next video, I'll be talking to you about the uses of a synthetic division. Thank you for watching. I'll see you next time.